Hello.
Hello, hello.
Yeah. Uh, okay, so we'll start inequalities. Uh, we'll do this section through problems because we don't want to spend too much time on theory. I think you already know the basic inequalities, right?
Yeah, I know AMGM and Cauchy.
Uh, so AM is greater than GM and Cauchy you already know. So we will discover whatever we need, whatever else we need, we'll do through problems. Okay.
Okay,
So this is the first one. Let A, B, C be positive real numbers, prove that this is greater than this.
okay.
So sometimes when you have to prove things like this, it is it is useful to just say that okay, you have to prove RHS is, let's say, greater than LHS. So can we try and find out what LHS minus RHS is?
Oh,
Like it's a simple comparison. Like just find out this value. If you can prove that this is positive, then it is done, right?
now let me try.
Hmm. You should get till here, I think.
Yeah, I have gotten.
So then if you take a common denominator, a plus b, b plus c, c plus a, notice that when you multiply this by a plus c and a plus b, this becomes a square minus b square, a square minus c square, right?
Yeah,
This becomes b square minus c square plus b square minus a square.
yeah,
And the second last one is c square minus a square, c square minus b square, right?
yeah.
So since ABC are positive, your denominator is anyway positive. You just have to think about the numerator. Technically, 12 terms should come from here, but 6 terms will cancel. Like plus b square c square and minus c square b square here, right? So what will remain is minus a square b square from here and a power 4. Similarly, from here b power 4 and my b power 4 and minus a square c square. Oh, plus a square c square gets cancelled with this, and we have minus b square c square comes from here. This is what is coming on top.
Yeah.
So can you say whether it is positive or negative, this thing?
Complete the square.
By multiplying by half and 2, right?
Yeah.
This is a common technique. This thing will be sum of 3 squares, right?
Oh, yeah.
Minus 2 a square c square. It will be half of a square minus b square whole square plus so on, 3 squares.
Yeah.
So the top part is positive, and therefore LHS minus RHS is coming out to be positive, so the inequality is proved, right? Now this is obviously like there's no technique to it, it's just simplification. The only important things to remember was grouping the right set of terms together and then factorizing it properly, right?
Yeah.
But sometimes even in IMO questions, there have been cases where people have just done simplification and gotten the answer. So it is important to realize that you don't always have to think of some clever solution. The solution can be some obvious thing like simplification. You
Okay.
understand? Not always will there be some very clever solution. And if you look for that all the time, maybe you will waste too much time on that. Maybe there is a simpler method which is just straightforward, right?
Yeah.
Let's look at another question. This is for real numbers x, y, z that satisfy xy plus yz plus zx is equal to minus 1. Show that x square plus 5y square plus 8z square is greater than equal to 4. This is similar to the previous one. So think of something similar.
I replaced the 4 by negative 4xy minus 4yz minus 4zx.
Correct. You can say that this is, let's think about this. And this can be written as x square plus 5y square plus 8z square plus 4xy plus 4yz plus 4zx, right?
Yeah.
Now what?
Now like group them, but I feel like I need an extra x square.
So, okay, you feel like you need an extra x square. Uh, Group some of the terms and see what is coming. Is there a way to group it as a sum of two squares? That is the thing, right?
I feel like it's x squared plus 4y squared plus 4xy.
Mm-hmm.
Maybe y squared plus 4z squared plus 4yz.
Correct. That way it is not fitting, right?
Yeah.
So why don't you think of a plus b plus c whole square is equal to this? Instead of just a plus b whole square, x square plus 4y square plus 4z square plus 4xy plus 4yz. No, it will not be 4yz, it will be 8yz, right? Plus 4zx minus 4yz plus y square plus 4z square, right? I'm
Yeah.
doing I'm doing this as one square. This becomes x plus 2y plus 2z whole square plus this is y minus 2z whole square, right?
Yeah.
So sometimes it might not be that you have to do just do two a plus b whole square. You could have done a plus b plus c whole square also, right?
Yeah.
So that is the trick for this one. Like you just write it like this, and this is greater than zero. Therefore, we have proved the inequality greater than equal to zero, right?
Yeah.
Okay. Third one is this. Uh, Show that for any natural number n greater than 1, show that for any natural number n greater than 1, uh, 2n factorial is less than n into n plus 1 whole power n. This is not so hard. You can figure it out, I think.
I'm trying to do induction.
Ah, induction might be very easy. Can you do it without induction? I think induction will be super easy.
Okay.
I mean, I'm sure you can do it by induction. Can we do it without induction also?
Okay. Let me try.
Uh, you can do the induction method later. For now, just try without induction. Using inequality stuff, AMGM or something. Two n factorial is a product of many numbers, right?
Yeah.
Till 2n. So,
So I consider this sequence
hmm,
the arithmetic mean of this sequence and the geometric mean.
you can do that. Uh,
So I think I get like n plus 1 over 2 whole thing to the power of n is greater than 2n factorial.
like this, right?
Yeah.
Something like this you would get
What is it? Dividing by 2?
by
Is it?
2n, right?
Yeah.
Uh, but this is not coming right, correct? Because the power will be 2n here, right?
Yeah.
Is it working out or not working out?
I'm trying.
Okay.
I think I should raise the power.
You can raise it to the power, but this sum is easy. This sum is just 2n into 2n plus 1 by 2. And there is a 2n there, so this becomes like this.
Yeah.
You get 2n plus 1 by 2 whole power 2n is greater than 2n factorial, right?
Yeah. So I get the left hand side.
You are getting lesser than, you are getting this. But that doesn't mean that this is lesser than this, right? This and this are different things. No?
Yeah, I know. But
So,
maybe they are somewhat connected.
so you could probably take the two inside and try to think then, right? So it will become 4n square plus 4n plus 1 by 4 power n, right?
Yeah,
If you can show that this is lesser than this, then it is correct, right?
yeah,
This is actually n square plus n, and this is n square plus n plus 1 by 4, right?
yeah,
Then that is not going to work because this is bigger, right? Basically, by doing direct AMGM on all the numbers, we are getting a less strict inequality, right?
yeah,
We are getting a more loose inequality. We want a tighter inequality, correct?
yeah,
So we'll think of applying AMGM, but in a slightly different way here. Uh, so think of the product of these 2n numbers as two groups of numbers. One is 1, 3, 5 till 2n minus 1. And the other group is 2, 4, 6, 8 till 2n, right? So if I do AMGM on this portion, right? So let's see what will come. It will be 2 plus 4 plus 6 till 2n divided by n should be greater than equal to 2 into 4 into 6 till 2n power 1 by n, right? Right.
yeah,
So this is what? This is 2 common 1 to n, which is n into n plus 1 by 2. So like this and n. So this cancels. You're getting n plus 1 is greater than equal to 2 common from every term. So it is 2 power n, n factorial, right?
yeah,
So we are getting n plus 1 power n is greater than equal to 2 power n into n factorial, right?
yeah,
Let's see what we get from here. See now that this is actually slightly better than before because at least we are getting n plus 1 and all, right? Power n. Let's see what happens here. We can say that uh, okay, we'll just first apply it. 1 plus 3 plus till 2n minus 1 divided by n is greater than equal to 1 into 3 into till 2n minus 1 root 1 by n. So we are getting this is the sum of first n odd numbers, right?
yeah.
So that is equal to n square, right?
Okay.
Sum of first n odd numbers is n square.
Uh,
You know that, no?
yeah, I think, but like maybe I have forgotten.
But you can prove it easily by doing GP AP formula, right? N by 2 first number plus last number, right?
Yeah,
So this is 2n and into n by 2, so n square.
yeah.
Also see 1 plus 3 is 2 square, 1 plus 3 plus 5 is 9, which is 3 square.
Plus 7 is 16.
Yeah.
Yeah,
So this is n square by n. So n power n is greater than equal to 1 into 3 into 5 into till 2n minus 1, right?
yeah,
So here we are getting this, and here actually I should not have written it like this. It is better to keep writing it like this only. Here we are getting n plus 1 power n is greater than equal to this, right?
yeah,
So now multiplying, you will get n into n plus 1 whole power n is greater than equal to multiplying this to this becomes 2n factorial, right?
Yeah.
Are you understanding what is happening?
Yeah, I just take the groups.
Take the two groups, do ANGM on both the separate groups.
Like, how do I come up with this idea?
Nobody knows. There is no way to come up with the idea. I mean, there's no nice way. It is just experience and practice. Like, there's no solution that I can give to you that you will come up with the idea immediately.
Okay.
Like, what you could do was what we did first, right? We did ANGM on the whole thing. It didn't work exactly, right?
Yeah.
Then you could have tried something else, or full foolproof method would be induction, right? You don't have to think much, you have to just do it, right?
Yeah.
But with some experience and practice, you will think in different ways. So this is just, it is really difficult to predict like how to come up with the idea. Like that is not something that anybody knows. So I can't help you with that, but we can see different types of problems, and once we have enough experience, these ideas will come easier,
Okay.
right?
Yeah.
Next one is this. Uh, we have ABC are the sides of a triangle. If ABC are the sides of a triangle, prove that prove that 3 by 2 is less than equal to A by B plus C plus B by C plus A plus C by A plus B is less than 2. So actually here you have to prove two different inequalities. One is this,
Okay.
right?
Yeah.
You can think of it as a two-part question. First, try to prove this. Later, we'll work on the second part. There is something that you need to know about triangles. There is triangle inequality, right?
Yeah. Like A plus B is greater
Ah,
than.
hmm. This is always true for any triangle. First, work on that first part, okay? One thing you should notice in this expression is that a by b plus c plus 1 is what? A plus b plus c by b plus c, right? And similarly, b by c plus a plus 1 is also a plus b plus c by c plus a.
Yeah.
Right?
Yeah.
So right now it is difficult to simplify this expression, but if the numerator was constant, it would have been easy to take it common at least, right?
Yeah.
So it would have been nice if we had a plus 1, plus 1, plus 1, and a plus 3 here, right?
Yeah.
Which is the same inequality. We are just adding 3 on both sides, right?
Yeah.
So this becomes 9 by 2 is less than equal to what we get is this plus 1 is this. So you can take a plus b plus c common. What you end up getting is 1 by b plus c plus 1 by c plus a plus 1 by a plus b, right?
Yeah.
This is what we have to prove now. This has happened because these terms are nice and symmetrical. One a by other two sides, b by other two sides, and so on. Therefore, we were able to add one and take common. So now in inequalities involving triangles and their sides, there is a very famous substitution that sometimes simplifies matters. The substitution that helps you solve inequalities like that many times is this. Call b plus c as x, c plus a as y, and a plus b as z, right?
Yeah.
So what we have here is if you add x plus y plus z, that will be 2 times a plus b plus c, right?
So divide by 2.
So what we have is 9 by 2 is less than equal to x plus y plus z by 2 and 1 by x plus 1 by y plus 1 by z, right?
Yeah.
So we have to prove actually that x plus y plus z multiplied by 1 by x plus 1 by y plus 1 by z is greater than equal to 9, which is much simpler. It is even simpler than this.
Yeah. Yeah.
Can you think of something famous that this means? This is a famous thing.
I don't know. Should
So
should I just like simplify the left hand side and divide the two no, multiply the two terms?
AM, GM, HM you have heard of. Harmonic mean?
No. Wait, I heard of, but
Okay, so I'll tell you. So so AM of two numbers was what? A plus B by 2, right?
oh yeah.
And AM of three numbers was A plus B plus C by 3, right?
Yeah.
Similarly, GM of three numbers was
Uh
cube root of ABC, right? Right.
yeah.
And HM of three numbers A, B, C is basically 3 by 1 by A plus 1 by B plus 1 by C. Now, why is that so? So what is HM first of all? HM is called harmonic mean, and harmonic mean is basically saying that if there are two numbers A and B that are in a harmonic progression. What is a harmonic progression? Do you
Like
know?
1/1 plus
No.
1/2 plus 1/3.
1 by A and 1 by B are in AP. If 1 by A and 1 by B are in AP, then A and B are said to be in HP.
Uh-huh.
Okay.
Okay.
Are you understanding what I'm saying?
Yeah.
If a sequence of numbers is in HP, it means that the reciprocals of those numbers are in AP.
Okay.
Okay. So if I have to find out the arithmetic mean of 1 by A and 1 by B, right?
Yeah.
If there are two numbers in AP, I can find a number in the middle, which is arithmetic mean of those two numbers, right? It will
Yeah.
be 1 by A plus 1 by B by 2, right?
Yeah.
So that number in the middle would be the number AM, which is one more term in this sequence, which is in AP, right?
Yeah.
So by definition, if you have a sequence of numbers which is in AP, its reciprocals will be in HP, right?
Yeah.
That is the definition of a harmonic progression. So when you take reciprocal of this, it will be A, reciprocal of this will be B, and reciprocal of this would be 2 by 1 by A plus 1 by B, right? That will be your harmonic mean between A and B. If you
Yeah.
simplify this a little bit, you will get 2AB by A plus B. That is your HM of two numbers, right?
Oh, yeah.
Similarly, if you have three numbers, let's say A, B, C, right? They are
Yeah.
in AP. Your AM of these three numbers is A plus B plus C by 3, right?
Yeah.
So 1 by A, 1 by B, 1 by C are, let's say now these ABC are in HP. So 1 by B, 1 by B, 1 by A, 1 by B, 1 by C are in AP, right?
Yeah.
So their AM would be 1 by A plus 1 by B plus 1 by C by 3.
Yeah.
Right? And the harmonic mean of now ABC would be called 3 by 1 by A plus 1 by B plus 1 by C.
Yeah.
So in general, for n numbers in a sequence, if the sequence is an AP, you do sum of the numbers by n, that is your AM. If the sequence is a GP, GM is basically product of the numbers whole power 1 by n, right?
Yeah.
Correct.
Yeah.
And if the sequence is in HP, you say HM is equal to n by summation of 1 by AI.
Yeah.
Okay. So now what we can do is we can prove the inequality that always AM is greater than GM is greater than HM. So AM is greater than GM, you already know. We can also similarly prove that it is greater than HM also. So for two numbers, let's see, it's a very simple case. You can say that AM of two numbers is A plus B by 2. And
Yeah.
HM of two numbers is 2AB by A plus B, right?
Yeah.
You can quickly show that this is greater than this. You can cross multiply, see A plus B whole square. It is equivalent to showing A plus B whole square is greater than 4AB,
Oh, then,
which is A plus B whole square minus 4AB greater than 0, which is A minus B whole square, right?
yeah.
So AM is always greater than HM. That is also true, right?
Yeah.
For three numbers also you can show this. By induction, it can be proved for n numbers also. So now in this question, what we are getting was this, right?
Yeah.
That's 1 by Z is greater than 9. Something like this we are getting.
Yeah.
So this 9 can be written as 3 into 3. And you were saying something like this, right? X plus Y plus Z by 3 bring here is greater than equal to, we have to prove 3 by 1 by X plus 1 by Y plus 1 by Z, right?
Oh, and oh,
This
yeah.
is AM and this is HM, right?
Yeah.
Obviously, the AM, GM, HM, the entire inequality is only valid for positive terms. The
Yeah.
inequality does not work if they are negative terms, okay?
Yeah.
So that is something that you need to remember. Here, since these are sides of a triangle, therefore the terms are definitely positive, okay?
Yeah.
Now for the second part of the question. Second part of the question was saying A by B plus C plus B by C plus A plus C by A plus B is less than 2, we have to show.
So I do the same thing,
So same thing as in,
like to plus 3 on
you
both.
could try that. You could try that. Then you would have A plus B plus C common. 1 by B plus C plus 1 by C plus A plus 1 by A plus B is less than 5, right?
Yeah,
And that would mean that you have, if you take it as x, y, z, you get 1 by x plus 1 by y plus 1 by z. And this is x plus y plus z is 2. So x plus y plus z by 2, right? So you have this, right?
yeah.
Okay, is less than 10 here. Hmm. Earlier we had a similar thing. We proved that it was greater than 9, right?
Yeah,
Now we have to show that it is less than 10. But this, I don't think this method is obvious now, because now you cannot use AMG and HM, because the inequality gives you the other side, the side that we have already used.
yeah,
Um, so here you have to think a little differently. Here, let's not do this because it doesn't help us now at this stage. Let's focus on this only.
okay.
Okay. And you can assume without loss of generality that A is less than B is less than C, right?
Yeah,
Because these are just sides of a triangle. There must be some which is greater, some which is smaller, right?
yeah,
So we can assume this, and in that case, we can say A by B plus C would be
smaller.
smaller than A by A plus C, right? Because here we are dividing by a smaller thing. So this is larger, right?
Yeah,
Correct.
yeah,
And B by C plus A, right, would also be smaller than C by C plus A, right? Because here B is less than C, right? And
uh,
denominator is same,
yeah, yeah,
correct?
yeah,
So don't touch the last one, let it be. And you can say the sum of these three, correct? This sum is less than equal to this sum, right?
which is 1.
This one is 1 by C plus A, 1 plus C by A plus B, right?
Yeah.
Correct. So,
Oh, yeah. And since it's in a triangle,
uh, so,
uh,
so this C by A plus B
yeah, it's less than 1.
is less than 1. C by A plus B is less than 1. So we can say that this is less than 1 plus 1, 2, right?
Yeah,
So what are we using here? We are using a technique which says that, like, if there are variables, multiple variables, you can assume some ordering between those variables, right?
yeah,
And you can look at your inequality, which is a collection of terms, in a term by term manner and try to get the inequality that you want. Like we want this expression to be less than something, right?
Yeah.
We want this to be less than something, and we want a bound on that. So I am trying to write each term as less than something, right?
Yeah.
And this term also is less than something. And I choose it in such a way that I can add these fractions, right?
Yeah.
Obviously, this is not super obvious. Like this is a tricky one, but it's important to keep looking at these types of questions and figuring out what you can do. Uh, then the next one. Okay, next one should not be so hard. Try this one. Again, A plus ABC be sides of a triangle. ABC are sides of a triangle such that such that BC by B plus C plus CA by C plus A plus AB by A plus B is equal to S, right? Where S is the semi-perimeter. Okay, we have to prove that the triangle is equilateral. So first of all, you should think about why is this an inequality problem, right?
Just like maybe it's greater than or smaller than S, and the equality holds when A equals B equals C.
Correct, correct. That is the idea. So actually, look at these terms, BC by B plus C, right? So this term actually, if just now we saw that HM of two terms B and C would have been what? 2 by
Oh,
1 by B plus 1 by C, right?
yeah,
Which is 2BC by B plus C, right?
yeah,
So actually BC by B plus C is like HM by 2, right?
yeah,
HM of B and C by 2,
yeah.
right? Okay.
Oh,
So,
so it's smaller than AM.
so correct. It is smaller than AM of B plus B comma C by 2, right?
Yeah,
So we can say BC by B plus C is smaller than what is AM of B plus C? That is B plus C by 2, right? Correct.
yeah,
Similarly, CA by C plus A will be smaller than C plus A by 4, right? And AB by A plus B would be smaller than or equal to, less than equal to A plus B by 4, right?
yeah. So just add
Just
everything.
add, if you add this side, it will become 2 times A plus B plus C by 4, right? So it is A plus B plus C by 2, which is equal to S, right?
Yeah,
So what we are getting is that this side is less than equal to S actually, right? But it is saying that it is equal, right?
yeah,
And equality happens in this inequality. AM is equal to GM is equal to HM happens only when
All the
terms are equal. The two things whose AM and GM and HM we are taking, they are equal, right? So that means only when A is equal to B is equal to C can AM and GM HM be equal, right?
yeah,
So therefore, it must be an equilateral triangle, because here you're getting this is less than equal to S, but it is given that it is equal to S,
yeah,
right?
yeah,
So here we are using the fact that HM is less than equal to AM, correct?
yeah.
Okay. I will write down a couple of problems that you can try.
Okay,
Uh, and next week's class, we can do problems from your past year's papers also.
okay. I can select some.
You can select some papers, like at least let's do like 2015 onwards, right?
Okay. So like
2015 till 2020, right?
inequalities.
No, not just inequalities.
But I
I
think
mean, it's
doing
up to you. Whatever you feel is better for you.
I think topic by topic is better.
Okay, topic by topic is better, then we can look at inequalities from last 5 years. Okay,
Okay.
that will help us try to get better at it. So we'll do topic by topic then. First inequalities, then we'll look at other types.
Okay.
So, okay, I'll just write a couple of questions that you can try. Um, A, B, C are positive real numbers. Show that A plus B by 2, B plus C by 2, C plus A by 2 is greater than equal to A plus B plus C by 3, ABC power 2 by 3. This is one. Then second one is let ABC be positive reals. Be positive real. Prove that A power A, B power B, C power C is greater than equal to ABC power A plus B plus C by 3. Okay.
I'll try them.
Now try these and also try the inequalities questions from last 5, 6 years. And
Okay.
we will discuss problems on that in the next two classes.
Okay.
Okay. I'll see you in next week.
Bye.
Bye.